Welcome back, everyone. Today, we're putting on our detective hats and stepping right into the shoes of a professional field technician. We are going to tackle one of the absolute most frustrating, yet totally satisfying mysteries in the entire IT world, tracking down the entity that controls your internet access. Okay, let's dive into this mission. Our goal in today's explainer is to master DHCP location identification and to learn exactly how to hunt down those rogue servers that can literally bring entire networks to their knees.
So here is the million-dollar question. Where does the DHCP server hide? You can kind of think of the DHCP server as the invisible traffic cop of your entire network. It's the one device responsible for handing out IP addresses. And look, without an IP address, your laptop, your smartphone, or even your smart TV, it's completely invisible, totally cut off from the internet. As a pro, if you walk into a building where devices just aren't getting online, finding this hidden server isn't just, a step in the process. It is the entire ballgame. Identifying exactly where this server lives right from the get-go is going to save you hours, literally hours, of blind troubleshooting and endless frustration.
Section 1. Locating the DHCP server. Consider this your mission briefing. Knowing exactly which device hands out IP addresses is the ultimate master key to solving internet connectivity issues. Section 2. Home networks versus business networks. Let's move to and see how this builds, because this distinction is absolutely crucial.
If you don't know who is supposed to be giving out the addresses, you're never going to know when an imposter sneaks onto the network, right? And the location of our hidden server changes completely depending on the environment we're walking into. Actually, the absolute biggest amateur mistake a technician can make is treating a massive enterprise network like a simple residential setup. Let's break this down. In home networks, things are pretty simple. The router or ONT provided by your telecom company is essentially an all-in-one box. It accesses the DHCP server, and that feature is just turned on by default. It automatically hands out private IP addresses like 192.168.1 something to everything in the house. But in business networks, a basic telecom router simply cannot handle the sheer volume of users. So, in a company setting, the ISP router usually just provides the raw internet line into the building. The actual DHCP server is a massive, dedicated piece of hardware sitting in an IT room somewhere, like a dedicated server, a heavy-duty firewall, or a core switch. If you try to troubleshoot a corporate network by messing with the ISP's entry router, you're looking for the DHCP server in completely the wrong place.
Section 3. How the address pool works. Now that we know where to look, let's transition to the underlying rules of the network environment to understand how our suspects actually behave.
Now, what's really interesting about this slide is that IP addresses aren't just tossed out at random into the void. Nope. The server operates using a strictly defined inventory, which we call a DHCP pool. Imagine a giant tank filled with a very specific set of numbers, let's say everything from number 10 right up to number 100. When a standard device connects, the server reaches into the specific pool and hands the device the very next available number. It's a highly orderly, sequential system.
But as you might guess, not all devices get treated equally. On one side, we have dynamic pool IPs. These are for your everyday devices, smartphones, laptops, tablets. They just pull an automatic address from that 10 to 100 range, and hey, if that address changes tomorrow, it really doesn't matter. But on the flip side, we have static IPs. These are for what I like to call your VIP devices. Think security cameras or those heavy-duty office printers. We manually assign them an IP address completely outside of the dynamic pool. Why? Because we never, ever want their addresses to change. Think about it. If a printer's address changes automatically, every single computer in the office instantly loses the ability to print to it. It's a beautifully organized system, right? Dynamic numbers for transient devices and static, permanent numbers for the VIPs. But what happens when this orderly system gets crashed by an intruder?
Section 4. The danger of the hidden server. Enter the climax of our detective story, the arrival of the disruptive intruder known as the rogue DHCP.
Out in the field, professionals call this the rogue DHCP, and let me tell you, it is the single biggest cause of those absolutely mind-bending network outages. Here's exactly how this escalating disaster happens, step by step. Step 1. A well-meaning customer decides the Wi-Fi is just a little too weak in the break room, so they go out and buy a cheap Wi-Fi extender or maybe a secondary home router. Step 2. They plug this new device into the wall, but, and here's the kicker, they plug the cable into the completely wrong network port. Step 3. Disaster strikes. That cheap extender comes right out of the box with its own DHCP server already turned on. It suddenly starts hijacking the network, aggressively competing with the company's main legitimate server. And Step 4. Complete and utter chaos. Half the network receives fake, conflicting IP addresses from the cheap extender and gets entirely cut off from the internet.
Just picture the reality of a rogue DHCP clash. You essentially have two routers screaming over each other, desperately trying to hand out IP addresses to literally any device that will listen. This creates an absolute nightmare scenario. This is exactly why some devices in the building are communicating with the legitimate server and working perfectly fine, while the unlucky victim devices connect to the rogue extender, get a completely random, useless IP address, and just show a no internet connection error. It's exactly why a technician can walk into an office and find half the computers working beautifully while the other half are completely dead in the water.
Section 5. The Golden Rule of Troubleshooting. Let's bring this case to a satisfying close by equipping you with the ultimate field technician rule.
So how do we solve this? As network detectives, we need a reliable way to fix this localized chaos. So the crucial point is, and I really want you to memorize this unbreakable law and put it in your toolkit forever. If some devices work and others don't, do not blame the internet line. Find the unauthorized router or extender plugged in by mistake and unplug it. Seriously, guys, do not waste your time calling the telecom provider to complain about the internet line. The internet is perfectly fine. The problem is coming from inside the building. Look under the desks, check the break rooms, trace those cables. Find that rogue device that some well-meaning employee just had to plug in, physically disconnect it from the network, and you'll watch the entire system heal itself almost instantly.
We've covered the differences between home and enterprise networks, how address pools keep things perfectly organized, and how a rogue server can literally tear all that organization apart. So I'll leave you with this final thought to carry into your next troubleshooting mission. Next time half a network suddenly goes dark while the other half works perfectly fine, who are you going to blame first? The internet provider or the rogue imposter hiding under a desk? Keep your eyes open, trust the golden rule, and keep learning.